horizontal transformations.
Today we're going to talk about horizontal shift of my parent functions. In my opinion, this is pretty easy, especially if we do it broken down like this, where we just do horizontal shift by itself. The important things to remember is that when I do a horizontal shift, it's going to be some number, and it's going to be grouped with the x. So it's a number grouped with x. All right? What that means is that I'm going to have some grouping symbol. It might be parentheses, or it might be one of the symbols from the parent function itself. All right? The other thing to remember is that it goes the opposite direction of what it seems. So in that case, plus goes left and minus goes right. All right, so if I add something inside with the x, it would go to the left. If I subtract something grouped with the x, it will go to the right. So let's take a look at what this would look like. So we're going to look at, I am trying to shift these some direction left or right, okay? Now, questions that might be provided with this might give you a shift and ask you how much it has been shifted. So in this case, let's start with y equals x. All right, if I want to shift this to the right 2 units. All right, I want to shift it to the right 2 units. This is a positive 2. So since I know it's going to go in, it needs to be the opposite. If this is positive, I know it needs to be x minus, and it has to be grouped with it. So in order to group it with the x, I have to put it in parentheses. So x minus, because it's the opposite, 2. So parent function is y equals x, shifted 2 units to the right, grouped x minus 2. All right, a lot of these are going to look very similar. So let's say I'm doing y equals x squared. It's going to look almost just like this, except it's going to be plus or minus whatever the shift is supposed to be, and then I'm going to have squared on the outside parentheses. So let's say I want to go left 3 units. All right, once again, I have to group it with the x. So grouping it with the x means that it's going to be x plus 3 grouped together, but then I can't forget my square, and that goes on the outside of the parentheses. So I have shifted y equals x squared 3 units to the left. Remember, opposite of the sign. Y equals x cubed basically looks the same, but instead of being squared or a 1, it is cubed. So let's say I want to go 4 units to the right. All right, should I add 4 or subtract 4? Well, if I'm going to the right, it should be minus 4. Y equals, group it together, x minus 4. All right, that's how I group it together. This is cubed, so this is cubed. So notice that all I'm doing is adding or subtracting grouped with the x in order to get my horizontal shift. All right, it's going to look the same for the rest of the parent function horizontal shifts.
Why couldn't the bicycle stand up? It was too tired.
So these next two, once again, are going to look very similar. Now in this case, my grouping symbol is the square root or the cube root. All right, so I have to make sure I pay attention in order to extend the bar of the root symbol over my added or subtracted number. All right, so y equals the square root of x. Let's say I want to go left 8 units. All right, so if I'm going left 8 units, that means it's going to be x plus 8 because it's the opposite of what it looks like. And in order to group it, I have the square root of x plus 8. Notice I extended that bar to include the plus 8. Square root by itself is a grouping symbol. So this is the parent function of y equals the square root of x, shifted to the left 8 units. When I deal with the cube root, as I said, it's going to look very similar. The only difference is that I have a cube root instead of a square root. All right, so let's say I want to shift this one to the right 7 units. Since I'm going to the right, and I know that if it's grouped with the x for a left or right shift, it's the opposite. So if this is positive, then it should be x minus 7. So y equals the cube root of x minus 7. Notice I extended the bar of the radical past the 7 so that the x minus 7 is grouped together. The last two examples follows the same deal. All right, the absolute value symbol is a grouping symbol itself. It's kind of like parentheses, except they are bars, the absolute value bars. And then the denominator is a grouping symbol as well. So some people will put this in parentheses, and that's fine. If that's easier for you to do, then by all means do it. But just by writing it in the denominator, that groups it. So let's say I want to do y equals the absolute value of x, and let's go 2 units to the right. So if I want a horizontal shift 2 units to the right, I have to make sure I do the opposite. So I have to say x minus 2, and I would group it by including the minus 2 inside the absolute value symbol. So since this 2 is grouped inside the absolute value symbol with the x, then this is a shift of 2 units to the right because it is the opposite of the sign. For the last one, for my inverse function, when I group this one, as I said, I could either put it in parentheses or not, just to have to make sure it's in the denominator, all right? So if I wanted to go 3 units to the left, all right, I know that in order to go left, I have to put plus 3, since it's plus 3 units. So the way this could look is I could have y equals 1 over x plus 3, and that's enough to group it, but it's okay to say y equals 1 over parentheses x plus 3. All right, if you feel more comfortable grouping it in parentheses in the denominator, then by all means do it. All right, so for this, we're looking at how to horizontally shift my different parent functions. I'm either adding or subtracting grouped with my x. Remember, it's opposite of what it appears, so if it's right, then it is minus a number. If it's left, it's plus a number. All right, and it has to be grouped with it.